This video is for section 3.3, properties of logs. So we're going to spend some time looking at manipulating logarithms, and the goal is to get to where we're solving equations with logarithms in them. All right, so it starts with a warm-up, which I actually planned on covering this up. And I would say pause the video, write these two in your notes, and try them. And here's number one. So sketch these graphs, and then try simplifying these. Pause the video and do that, and then start the video back up and check your answers. So 7 to the x is going to look like an exponential, like we have here. Try to zoom in a little bit there for you. And then I just did a real short table of values here, and I got this point over 1 up 7. And remember, unless I've shifted this around, my y-intercept will be 0, 1. And then if I graph its inverse, recall it should look like a reflection over this line. So I reflect this over the line. Should look like this. My y-intercept becomes the x-intercept, and when you have inverses, your x and y switch. So my over 1 up 7 becomes over 7 up 1. This is log base 4, and you're taking the log of an exponential with the same base. So those undo each other, and I'm left with 3x. This, if you ignore the 1/15th and just think about simplifying this log 3 of 243, if I add an equal and add an x and rewrite it as an exponential, because I don't know what log 3 of 243 is, but if I rewrite it, I can think, oh, okay, 3 to the x equals 243. If I write 243 as 3 to the something, 243 is the same as 3 to the 5th, so x is 5. So all of this simplifies to 5. So then I have 1/15th times 5, which is the same as 5 over 15, or 1/3. Okay, that's just a little review. This is what we're going to look at today, rewriting. This is change of base, and then we're going to learn all about these various log properties. Okay, change of base. I think you probably learned this in Algebra 2. A lot of your calculators will do different bases, like an 84 will do different bases. If you go to math, and then you go down until it says log base, right here, and if I hit enter, I can put any base in here. Remember, the log button right here is base 10. Math, I think it was A, will let you do change of base on an 84. However, the 83s do not have change of base. So on an 83, you need to actually know how to change the base. So here's your formulas for change of base. So if you have a log with a base A and you'd just like to change it to a different base, you would divide log base B of x over log base B of A. So here's how I remember what goes on the top and what goes on the bottom. If you look at this x, it looks like it's over top of this A. So log of A goes on the top, log of x goes on the top, log of A goes on the bottom. This one is actually one you may use a lot, changing to a natural log. So this would be natural log of x over natural log of A. So let's see what these look like in your calculator. I didn't want all these answers to be here, so I'm kind of just going to cover these up, and we're going to do this in the calculator. I'll rewrite it also. So common logs are logs with base 10. So this says evaluate using change of base with common logs. So this one is currently a base 4. I want to change it to a base 10. So the 25 goes on the top, the 4 goes on the bottom, and what I'm changing them both to is a base 10. So I just put my new bases here, log base 10 of 25 divided by log base 10 of 4. So the base 10 is the button in the calculator. So I can just hit the log button and do 25, and I get 1.39794. And then I can do the same thing, log of 4, log of 4, and then hit enter, and I get 602, and I divide them. So now I have evaluated this. Now, if you have an 84, you would do math, go down to A, I would put a base 4 in there, and a 25 in there, and I should get the same number, 2.32, and I do get the same number. Okay, now often it's going to ask you, or you're going to want to turn it into a natural log. So natural logs are your ln. So if I want to change this base 3, remember, pause the video to write these problems down. If I want to change this base 3, I'm going to divide natural log of 17 by natural log of 3. Put this in your calculator, put this in your calculator, do the division. Okay, this is the big part of the lesson, the properties. They're pretty important. You will use them a lot in this class and in calculus and possibly other places, whatever you're taking next. Okay, so the properties are right there. I assume they're in your student handout. I hope so anyway. This one's called the product property. This says if you have the log of two probably expressions multiplied together, multiplication becomes addition, which makes sense. Multiplication makes things bigger. Addition makes things bigger. So I can just separate it out. Log A of u times v becomes log base A of u plus log base A of v. All these same properties apply to a natural log or a log. Because remember, a natural log is just a log with a base e. So a natural log is a log. Division becomes subtraction. Just remember, division makes things smaller. Subtraction makes things smaller. So if I'm looking at this, this would be, I have a single log and I want to separate it into two logs. We will also spend a lot of time going in the other direction. We have two separate logs and we want to rewrite them as a single log. So both directions here are important. This one's a little bit hard to see and probably the hardest one to recognize in a problem. This exponent right here hopped down in front of the log. So this exponent is here now. So n times log of u, and the exponent here is gone. All right, let's just do some problems because honestly, those are where it starts to make sense. All right, so this says, you're going to want to pause and write this down. Write each logarithm in terms of natural log of 2 and natural log of 3. So this is one where I currently have a single log and I want to expand this out into 2 logs or 3 logs, however many I need to do. So if I notice right away, 2 times 3 is 6. So I'm using the product property on here. So I'm just going to flip back here real quick, show you the product property. Hopefully you have your student notes in front of you. That's this one. 2 things multiplied together, I would separate them into addition. So first thing I'm going to say is, well, natural log of 6, I could write it as natural log of 2 times 3. And that if I have if I'm taking the log of 2 expressions or numbers, whatever, multiplied together, multiplication becomes addition. So I have expanded this out from a single log to 2 logs. These are equivalent, and I've done what they asked. I've written the logs in terms of natural log of 2 and natural log of 3. So it's just a different way of writing this. The natural log of 6 is equivalent to this. All right, this one, I have division. So I'm thinking I'm going to use the quotient property, where division becomes subtraction. So I'm going to say quotient property. And I'm going to tell you right now, we're also going to use the power property. You might not see it yet, but we will in a minute. So this is the power property, where that exponent here hop down in front. So let's first kind of do the division. So if I have natural log of 2 divided by natural log of 27, I can say, well, this is the same as natural log of 2 minus natural log of 27. So that's the quotient portion of this. But remember, up here, they said, write it in terms of natural log of 2 and 3. Well, I got a natural log of 2. This is not a natural log of 3. But if you think about it, 27 is the same as 3 to the third. So I'm going to say, all right, well, let me rewrite that. Let me write natural log of 2 minus natural log of 3 to the third. Okay, now I don't want to leave this because I want to continue to expand it all the way out. And this said, if I have an exponent, which I have in that problem, I want to hop it down in front. So I want to take this exponent, I'm going to grab a different color here, and this is that power property. It says if you have an exponent, you can get rid of that exponent and hop it down in front. It's going to look like a constant multiplied by this natural log. So now I'm going to have natural log of 2 minus 3 times natural log of 3. So I've expanded it all the way out. Everything is in terms of natural log of 2 and natural log of 3. Notice this is a plain old 3. Up here I had a 3 to the third. I can't leave it like that. They want a plain old 3. So now it's expanded out, all natural logs of 2 and natural logs of 3. Okay, let's keep going. That's the solution. We already did that. Okay, these are your turns or you tries. So you also have the answer here, but I'm going to say pause the video and give these a try. And here is your answer. And then I am going to write in my work here. And then you are not going to peek at this until after you have paused the video. So this would be log 10 of 3 plus log 10 of 5 to the third. Oops. Yeah, 5 to the third. And then I would keep my log 10 of 3 because it's asking me to write them as log 10 of 3 and log 10 of 5 plus 3 log 10 of 5. I don't know why there's a 2 here. I think that should be a 3. Yeah, that should be a 3. Because 5 to the third, oh, wait a minute. No, that's 125. I think there's maybe an error in this problem. 75. Okay, I am actually going to have you change this to 125. Yeah, and then that will work. Okay, good thing we did this. 125, that should be. Okay, and then this one, you want to use the quotient and the power property. So see if you can get to this answer. And if you have questions on these, we can answer these in class. Okay, let's say, so this is just explaining. Sometimes you'll want to combine into a single log, and sometimes you'll want to separate or expand. And this is all getting ready for solving equations. So we just did a couple where we expanded. And now this is going to be expanding also. I think probably after this example, I'll pause and maybe put the rest in a different example. So this is just expanding. It didn't tell us what logs to use or anything in particular, but it says use the properties to expand. So the first thing I notice about this is I have 5 times x to the third times y. So I know I'm going to use product property because I have all that multiplication in there. I also have an exponent, so I know I'm going to use power property. When I'm done, this should be all expanded out. So the first thing I'm going to do is separate this into log 4 of 5 plus log 4 of x to the third plus log 4 of y. So it's going to look like this. Log 4 of 5, remember multiplication becomes addition, plus log base 4 of x to the third plus log base 4 of y. Okay, so I've expanded it out, but I need to do one more expansion and take that exponent, use the power rule, and have that down in front. So my final answer will be log base 4 of 5 plus 3 times log base 4 of x plus log base 4 of y. So I've taken all this multiplication, separated it out into 3 separate logs with addition. Okay, I see division. So I know I'm going to use the quotient property. Remember, division becomes subtraction. And I actually am going to use the power property on this one. You might not see it yet, but the first thing I want you to do is think of another way to write a square root. So I could write this as 3x minus 5 to the 1/2 over 7. So I'm going to start by rewriting that. That's where the power property is going to come in, that to the 1/2. Okay, so division becomes subtraction. So I'm going to have natural log of 3x minus 5. Subtract natural log of 7. So it's numerator divided by denominator, so you do top minus bottom or numerator minus denominator. And then I forgot my exponent on here. So this, I want to use the power rule and hop that down in front. So these are all equivalent. I can put equal signs there. So 1/2 natural log of 3x minus 5 minus natural log of 7. So I've expanded that all out. There's really nothing else I can do. All right. This is the solution, which we just did. Okay, this is a U-try. So I would, before this video ends, like you to give this one a try. I'm going to tell you, you're going to use quotient and power. I'm also going to give you a hint. You might want to write the square root of y as y to the 1/2. So after you've paused and tried it, here is your answer. Okay, that was expanding. So the last example we expanded. In the next examples, we're going to condense. So I'm going to do that in a different video.